go with here the hands-on of this. So let I just open that Xilinx Vivado. Okay, as it will take time. So if you are having any query, any doubt, you may ask. Okay. So as it is sequential design, so I just open my previous project, that is of your sequential. Okay. So here I am taking that new source. Okay. Yesterday we have seen that D flip-flop. Right now here we are going with that new source. So plus, okay. Then add or create design source. So next. So what here, create file, and later than that I am having that shift register. So sh shift underscore reg or register underscore, I can see that is 4-bit. Okay, it's very simple. Okay, then finish. So what my inputs are? कौन-कौन से inputs है मेरे पास में? Clock, or before that clock I am having a, then clock. Okay, clock. Then what I am having? Reset. All are inputs. What my output is? Output is only one, single. Okay, you can check it here. Sorry, you can check it here. Output is only one. I am having that only one outputs. Okay, so this is my output. Okay, okay. So this is a shift register. So first here you have to make it set as top. Set as top. Okay, double click here, shift register, the program is open. And what here we have to write? We have to just write the program. So what my output should be? It should be which data type? It should be which data type? Register. Okay, output should be register data type. Then here I have to define intermediate output. So that is of your register B, comma C, comma D. Okay. Now we will check by both the way. We will check by both the way. Okay. Then what happened here? I have to just write always block. So always at the rate, what happened? Pause age of the clock. Okay. Pause age of the clock. What head should be? I have to first check if my reset is 1. Okay. So what here? Begin and end. I just have that multiple statements. So begin, end. Okay. So what here? So I have to initialize B equals to 1 tick B 0. Okay. C equals to. So what my C equals to? 1 tick B 0. D equals to. Okay. D equals to 1 tick B 0. And what my E equals to? What is that? 1 tick B 0. Clear? If all these are here. Clear? Else. What happened else? If reset is not 1, that means else condition. So in else condition, what happened? In else condition. So if I'm just writing that B equals, sorry, again I just start with begin, multiple statements we are having. So begin, there is an end, and I just write it as, B equals to A. Okay. Then what happened? Next is C equals to B. क्या हो रहा है हम सिर्फ चेक कर रहे हैं, हमको पता है कि क्या होने वाला है. Then D equals to C. Okay. And then what happened? Last one is E equals to D. Okay, very simple. End, begin, end, and then end models. Are you getting this program? Okay. Are you getting this program? Very simple. Okay, is that clear? Yes. Okay, so save it and let's check. Okay, I am also checking the simulation. So shift register. Okay, so first we will check their RTL schematic. First we will check their RTL schematic. So open elaborated design. Okay, and let's check whether it will be shift register or D flip flop. Whether it will be work as a shift register or D flip flop. Let's just check. Yes, what happened? We have written the code for shift register, but here you are getting a D flip flop. It's not a shift register. Are you getting this? Is that clear? Is that clear? Do you find only one flip flop? यहाँ पे सिर्फ आपको एक ही flip flop दिख रहा है. So it's not shift register. Though you have written that B equals to A, C equals to B, D equals to C, E equals to D. But because of blocking assignments, what happens? A goes to B, but updated B will goes to C, updated C will be goes to D, and D will execute to E. So these statements are executed sequentially, not parallelly. That's why here you are getting a flip-flop, D flip-flop. Is it clear? Do you find that on your screen? It's a flip-flop, not a shift register, because in shift register we are having how many of flip-flops? शिफ्ट रजिस्टर के अंदर कितने फ्लिप फ्लॉप चाहिए आपको? We should have a fourth D flip flop, but here it generate only. What happened? Here it generate only single flip flop. Yes, okay. Is it correct? So fine. So where we have to do the change? So हमको कहाँ पे change करना पड़ेगा? Can anyone tell me? Yes. कहाँ पे change करना पड़ेगा? In the program? Anyone? In the programs to do or to work as a shift register code. हाँ, code में कहाँ पे change करना पड़ेगा? That's correct. Operator. Yes, either operator or what happened? Either here you have to do the operator or या फिर क्या करना पड़ेगा? We have to change their sequence. Now let's check what happened. अभी हम check करते हैं कि क्या हो रहा है यहाँ पे. Okay, so let's check here what is going on. यहाँ पे हम check करते हैं. अभी क्या किया मैंने? E में क्या गया? D में क्या गया? C. Okay. C में क्या आया? B और B में क्या आया? A. Now let's check. I just save it and reload the schematic. Now let's check what happened. Check करते हैं क्या मिलेगा आपको यहाँ पे. So that's why when we use blocking assignment statement, the sequence is very, very important. So let's check their schematic. Now let's check. Are you getting here that 4 D flip flop? Yes. Are you getting here that 4 D flip flop? So my input is going here first. The output of first D flip flop becomes the input of second. Second output becomes the third input, and third output becomes the fourth output, and the final output is coming out. Clear? So it is a B register, C register, D register, and it is E registers. Okay. So all resets are here. All clock are synchronous. Are you getting it? Are you getting this? Yes or no? Yes. Yes. Fine. Yes. Okay. Now here one is very very important rule is that, or it's a thumb rule. Don't mix blocking and non-blocking assignment statements. Don't mix this blocking and एक ही प्रोग्राम में एक ही ऑलवेज ब्लॉक में ब्लॉकिंग और नॉन ब्लॉकिंग दो अलग अलग स्टेटमेंट नहीं होना चाहिए. If you are using blocking, so use it, all the statements should be blocking. Use all the statements should be blocking. If you use non-blocking, use all the statements should be non-blocking. Clear? So this is a thumb rule for the design. So avoid it to the mixing of your blocking and non-blocking. Clear? So let's check here. If you are going with that non-blocking, so I just make it non-blocking. It's a non-blocking. it's a non-blocking, it's a non-blocking. Okay, and even if your sequence is changed, that means if you are having that B come first, okay, then E goes later, last one, and here this is come first, sorry, it comes second. And let's try what happened. यहाँ पे हम check करते कि क्या हो रहा. Okay, so all are having that non-blocking. It's a non-blocking. It's a non-blocking. It is also non-blocking. So save, reload the design, and let's check what happened. What happened? So are you getting this? Let's check the schematic.
जब पहली बार जब तूने कैसा बनी थी वो बोल रही थी
So
वैसा तो आइडिया बोल रही हाँ ना हम तेरी मर्जी जो करना है वो कर तेरी घर पे
sorry, what happened here? It is shift registers. Okay, so this is my D flip-flop. I want to just verify their functionality. So I just write here the test bench. So go to plus, then add or create simulation source. Go for next, create file. Right here TB underscore, later than that SH shift register or SR, later than that TB underscore shift register 4. Whatever the names you can give here. Then finish. Okay, there is no input for your test bench. Okay, so double click on test bench file, and here just now here inputs are your register. So only one input for your block. So what is that? It is of a register A, then there is a clock, there is reset. Okay, what your outputs are? Outputs are wire, so that is of your wire E, clear? And here you have to mention here you have to mention your shift register. So UUT. So what their sequence are? First is A, then is clock, then is reset, okay, and then output. Okay, so we initialize or we instantiate here my design, pre-design. Then just write their shift test cases. So I just write here that initial. So initial, okay. Then what is that? Begin, end, in between begin and end, and here I have to just provide that test cases. So initially I'm making that reset is 1. Okay. Let us assume that, so after certain duration, let us assume that hash 25. Okay. Reset becomes 0. At the same time, initially I'm just making that clock equals to 0. Okay. D equals to 0. Sorry, it's not D, it's A. So A equals to 0. Okay. Then we wait for 25 nanoseconds, and after that 25 nanoseconds, I want to make that A equals to 1. Okay. Now here I am just providing that only input A. So after after 14 nanosecond. Okay. So what my A becomes 0. After another 17 nanosecond, my A becomes 1. Okay. And I just repeat it. And I just repeat the same thing. Okay. I just repeat here that 14 and 17. Let us in that. Whatever you can change here the time, no problems. Let us in this is 18, it is a 15. Okay. So it is a 1 0 1 1 0, and just I repeat the same thing. Okay. And once it is reached up to whatever that, we are waiting for 15 nanosecond, and then we will do that dollar finish. यहाँ पे हम क्या करेंगे, dollar finish. Clear? Then this dollar finish is done. Now we have to generate the clock. So how we can generate the clock? So for that we use always. So after every, let us say that after every 30 nanosecond, my clock should be not a clock. Whatever the times, here you can take it. So let here I am taking that 30 nanoseconds. So that clock period becomes 26. So this is my simply a test bench. Okay. Save and run for your test bench. So before running that, it should be set as top model. So let's check. So run simulation. Okay, let's check the output waveform whether it will work as an shift register or not. So to get the output, it should take 4 clock pulses. Whether it will take 4 clock pulses or not. So let's check one by one. Okay, let's check one by one. Now let's check initially what at rising edge. Okay, this is my A. I'm taking the A is here clock. So initially at rising edge, what my reset is 1. So output becomes 0. Okay. Now at first rising edge, what my input A is. अभी मेरा first rising edge पे input क्या है? So input is shown as 0. Okay. My output is still it is 0. No problem. So at second rising edge, at my first rising edge, I just write here that my input is A equals to 0. So my first bit is 0. I'm just writing from this end to this end. Okay. At next rising edge, okay. At next rising edge, okay. What my input is? My input is 1. At next rising edge, my input is 1. But it is my second rising edge. Okay. This is my after reset. Okay. This is my first rising edge. It is my second rising edge. Now what happened at third rising edge? So at third rising edge, my input is, again it is 0. My input is 0. Okay. Now at fourth rising edge, let's check. At fourth rising edge, what my main input is? 1. What my input is? 1. Clear? Now at fifth rising edge, okay. At fifth rising edge, my output is 1. I am getting my output is 1 at fifth rising edge. Okay. And just before that fifth rising edge, at fourth rising edge, my output is 0. Okay, my output is 0. Now at fifth rising edge, my input is 0. So you can check it. This one goes to this one, it will take 4 clock pulses. So you can also check here, just that means just by observing you can also check it. यहाँ पे भी आपको दिखेगा. Okay, what happened here? यहाँ पे चेक करो आपका आउटपुट 1 कब आ रहा. ओके आपका इनपुट 1 कब है वो सबसे पहले चेक करो कौन से राइजिंग एज पे आपका इनपुट 1 है. ओके लेट गो विद दिस. So is it on this rising edge? Is that my input is 1? No, it's a 0. So on this rising edge, my input is 1. So यहाँ से लेके that means at 65 nanosecond से 65 nanosecond से लेके when you are having that the output is 1. आपका output कब 1 आ रहा? That is of your around 143. So it will have 4 clock pulses. Let's check. This is my first clock pulse. Okay. It is my second clock pulse. It is my third clock pulse, and at fourth rising edge, so it is having 4-bit shift register. Similarly, ये वाला जो 0 है, ये भी आप 0 चेक करो. ये आपका 0 कब आपको आउटपुट में मिल रहा है? So this is my first rising edge. It is my second rising edge. It is my third rising edge, and at this, यहाँ पे मुझे आउटपुट क्या मिल रहा है? On this rising edge, my output is 0. Are you getting it? Are you getting this? Yes or no? Is that clear? Is that clear? So you can just check it. When my input is 1, this is on my first rising edge. This is my first. This is my second rising edge. It's my third rising edge. And on fourth rising edge, I am getting the output is 1. So it will take that 4 clock pulses. Similarly, अगर आप यहाँ से चेक करोगे, so on this rising edge, my input is 0. So ये मेरा 0 आउटपुट में कब जा रहा है? So it's my first rising edge, it's my second rising edge, it's my third rising edge, and on my fourth rising edge, what my output is? 1. Sorry, output is 0. So it will take. Once again, यहाँ पे वापस चेक करो, ये rising edge पे मेरा इनपुट क्या है? 1 है. तो ये आउटपुट में कब रिफ्लेक्ट हो रहा? So first rising edge, it is my second rising edge, it is my third rising edge, and on fourth rising edge I am getting the output is 1.